the NLM chapter, and we will talk about the types of question and what kind of points we have to use in those questions. So now start. So in NLM, one varieties of question can be like, first of all, we should understand pseudo force, pseudo force, pseudo forces, accelerations, and frames. So when, let's say, just for clarity, I'm giving a scenario. Let's say there is a body that is rolling here. Sorry, let's say this body is rotating and having some alpha angular acceleration and some omega angular velocity, and the center is some ACM acceleration. And there is another point, let's say B, A point, which is accelerating with an acceleration, let's say AA, in the frame of B. Let's say there is a point B which is in its frame. This A point is moving with some A acceleration, or let's say it is A1 acceleration, and as observed from the ground frame, which is at 0 acceleration and at some velocity V1, this B point is having some acceleration A2. Now this acceleration A1 is with respect to B. So if I sit on this frame A, then the pseudo acceleration will not be equal to minus A, because this acceleration was measured in an accelerating frame. So we need the total acceleration as measured from the inertial frame. So the total acceleration of this would be this acceleration in this frame plus acceleration of this frame, which is A1 plus A2 is the total acceleration of the A in the frame of ground. And now if I sit on the point A, the acceleration, pseudo acceleration will be A1 minus A2 vector, acceleration vector in the opposite direction. This is, so this would be the pseudo acceleration, and the any point here P with dm mass, that would feel minus A1 into minus A2 dm pseudo force due to this accelerating frame. And if I sit on B frame, the pseudo acceleration would be minus A2 and the force would be minus A2 into dm on this mass in B frame. So taking the frame of the point which is accelerating, and this is a translating frame, means it is translating frame. Means by saying translating frame, I am saying that the axis of this B, which is let's say here x and y in the upward direction, and z is coming out of the page. So let's say these are the axes associated with this B point, and as this B point accelerates, this x, y, z directions remain constant, while the object may accelerate in this direction or in this direction. The x, y, z coordinates do not rotate, they remain pointing in the same direction. So this is what I'm calling translating frame. Now if I take another point, let's say C here on this body at some r1 distance, so this would be having some centripetal acceleration in this direction, and due to this ACM, there will be some acceleration to it. Let's say this C point is here with some vector r1 vector, then this C point is having an acceleration, some tangential, some centripetal, and some in this direction. So total acceleration would be equal to, let's say, alpha into r1 vector plus this ACM vector minus this omega square r1 vector. That is the total acceleration of the point C with respect to this AC, with respect to the ground. And if I talk about with respect to CM, this point is rotating about the CM, and means any point I can take, this point is rotating about this, so I will take the rotation of this centripetal acceleration and this tangential acceleration. And now if I have to go to the ground frame, I will add this acceleration of this point also, which is ACM. So this is the total acceleration of AC of this point. Now if I have to sit on this point, means if I have to take the frame of C, in C frame, the pseudo acceleration would be equal to minus alpha cross r1 minus ACM and plus omega square r1 vector. Means there would be some pseudo acceleration outward, some ACM in this backward direction, and some r alpha which is in this direction will become in this direction. So this total is the pseudo acceleration, and if I multiply it by the mass of the point P, that would be the force acting on the point P. Pseudo force acting on the point P would be equal to this acceleration into the dm mass of the point. So means this is a pseudo force due to this frame. And again, I didn't take any rotating frame. The axes are fixed in the direction, x, y, z axes are fixed in the direction. Only the point is accelerating here in this. Means it may be it may move little bit here after some time and then go back, or maybe take circular path, any curve path, and the axes are not rotating. So this is a translating frame again. But let's say I have to take the frame of the ACM, again translating. So because this ACM is translating, there will be some pseudo acceleration minus ACM from the frame of CM. So there will be this pseudo acceleration, and the force on the mass DM would be equal to minus AC DM. And one, I would say, one useful thing here is that when we calculate about the ACM, there is any constant acceleration Z on the body. Let's say there is a constant acceleration A on the body at each DM element. Then the torque calculated is, this is the force R cross A DM, when integrated means calculated all over the body, which becomes the total torque on the body due to this pseudo force. That would become, because this A and A is constant, and this we just need to integrate this RDM, so it simply becomes RCM cross A pseudo force, and where this R vector from the CM, this position vector are taken from the CM point, R from the CM, and the CM is at 0 distance from the CM, so that's why this whole value becomes 0. So when calculated from the point, this accelerating point, the pseudo forces will not produce any torque on the body about the CM. Now moving ahead, now if I take the CM frame, which is only if I'm taking only translating frame, then in that case again this would be the acceleration on each point of the body, and the mass on the P point would be force on the pseudo force on the P point would be equal to Fp pseudo would be equal to this minus of ACM into the DM mass of it. Now if I, instead of taking translating frame, if I take a rotating frame, let's say I take a rotating frame, some omega 1 acceleration, let's say I take a frame, this body is moving with some, let's say, omega 1 acceleration in this direction, and I take a omega acceleration in this direction, and I take a omega 1 acceleration in this direction, and alpha 1 angular acceleration in this direction. Let's say it is lesser than omega and alpha. Then in that case, the body will goes, as my axis is rotating also now, the angular velocity will appear to slow down, because let's say if I rotate my axis along with omega angular velocity, then the whole body will start to appear at rest. So it is clear that if I rotate my axis, then the relative position of the body with respect to the coordinate gets affected, means the angular position gets affected. So in a rotating frame, the omega and alpha are affected, while in a translating frame, omega and alpha are not affected. The body, both in this frame, and in this frame, in all of these frames, means in all the translating frames, the omega and alpha are unaffected. But if I take any rotating frame, then there would be some change in the apparent value, means the observed value of the omega and alpha in the frame. Now let's say I'm talking about this frame rotating, this a frame with origin at this point ACM, and okay, and the axis are rotating with some omega angular velocity in this manner. Let's say x-axis was in this direction, y was upward, and it was rotating with some omega 1 and alpha 1. Then the apparent omega, let's say omega dash, becomes omega vector minus omega 1 vector, while the alpha dash vector will become alpha vector minus alpha 1 vector. That is the relative angular acceleration and relative angular velocity from the frame. And because we are taking a rotating frame, due to the rotating frame at any r distance from the origin of that frame, there would be some omega square r minus r centripetal acceleration. So at this point, which is at r vector, the pseudo acceleration at p would be equal to, from this frame of the ACM, first of all there would be minus ACM, and then there would be, because the frame is rotating with some omega 1 angular velocity, we need to add omega 1 square r, which is in the outward direction, in this direction, and then we need to add some tangential acceleration, which is minus alpha cos r vector, where alpha 1 cross r vector, if it was in this direction, then we will take the negative. So this is the total pseudo acceleration, and if I multiply it by the dm mass of the point P, I will get the dm force acting on the point. So the pseudo force F pseudo on the dm mass would be equal to this total pseudo acceleration multiplied by the dm mass of the point. Now the next thing is, if I want to, let's say, write an equation, balance equation for this dm point, then I would, let's say this is a small dm element here. Now for this dm element which is having some centripetal acceleration, the acceleration observed in this rotating frame of the point P would be equal to, because this is the omega dash, so there will be some centripetal acceleration omega dash r, omega dash square r cap, sorry r vector, that would be the centripetal acceleration, and this will produce some tangential acceleration alpha dash cross r vector. And because the point is itself accelerating from its frame, so okay, so because ACM is added already in each point, so when I sit on this frame the ACM will get removed and I will get only these values. So this is the observed acceleration of P in this frame, and to balance this force, this dm mass, we know that on this P particle in this frame, in this rotating frame or the ACM, there will be some pseudo force in this is the pseudo force where omega square r, omega 1 square r dm is in the outward direction, which is where omega 1 is the omega of the rotating frame, and ACM would be in this direction, ACM dm would be the force in this direction, and minus alpha rk would be the force in this direction parallel to the tangent, so that is the acceleration in this direction, and multiplying by the dm mass, that is the force. So these are the forces on this, and this body has to rotate in this circle, and this needs to get this centripetal acceleration and this tangential acceleration in this direction. So let's say there is some force F in this direction and some F1 and F2 forces in these directions, and this system gives a net value of acceleration. Net force of this body should be equal to this, because this is the net acceleration of the body in this frame, so the sum of all these forces should give this total force. Okay, so that's how we will solve in the frame. Pseudo forces will be like this, and the observed acceleration will be taken, and we will balance the forces so as to explain the observed acceleration and observed phenomena. And one more thing, if there is any real force, for example there is any normal force in a frame, in any frame, if there is any normal force or gravitational force or any other kind of forces, then these forces remain in other frames also, means a real force cannot be removed from any frame, real force exists in all the frame. So because that's how can they disappear? By changing the frame. The pseudo forces are only introduced to make the physics laws work properly, nothing more than that. So the real forces always exist, but the pseudo forces only exist when we go to the rotating frame. And this was all about frames. When we calculate the torque about any point, we have to sit on the frame of that point, that is we take the translating frame, or maybe we can take the rotating frame also, but the rotating frame will also cause this much complications, so we can, it is our choice if we want to take translating frame or rotating frame also. We can take the frame according to our is, no frame is wrong, we can take any frame and solve in their own frames, because the laws are such that they must be applicable in all the frames after including this pseudo force. So you can solve from any frame, there is no issue of the frame, and just make sure that you don't make any mistake. Translating frames are very easy, while the rotating frame have some complications like this omega square r. This translating frame, in the translating frame, the acceleration is, the pseudo force is not dependent of any position, while in this case this is dependent on the position from the point of origin of the frame taken. So, and also angular momentum is also calculated about the point. So again we need to, whenever we have a reference, whenever we are given a reference point, then we have to take the frame of it also. So for calculating torque about a point or angular momentum about a point, we don't just take the point but also the frame of the point. We need to know that if it is moving with some velocity or acceleration, we need to consider all these values. Now friction. To understand the case of friction, means when we study the friction related questions, we have to solve the question in this manner. Let's say there are two surfaces and there is possibility of any friction. Let's say we don't know if there is any friction or not. To judge the friction, let's say this is mass block 1, block 2 with moving with some velocity v1, this is moving with a velocity v2, and let's say if the friction is removed, then this block will have the tendency to accelerate with a1 star, and this block will have the tendency to accelerate with a2 star. Then So first we make two cases, whether these are sliding when their velocities are different, when these bodies are moving with some different velocities. Let's say it is moving in this direction more than this body, then means it is relatively moving in this direction with respect to this body, means there is some relative motion. There would be some kinetic friction acting, which is a constant value, which is given by mu k into n. And in that case, let's say it is moving in this direction more than faster than this, means relative to this point this body is moving in this direction, then this body will apply friction force on this direction Fk in this direction, and as a reaction the friction force on this body will be in this direction. So this is how the forces will act. And let's say if this was moving in this direction relative to it, if I sit on this body, this object will look to move with some velocity in this direction, then we can say that the friction it should apply on this would be in this direction Fk, and on this body would be in this direction, means the friction tries to make them move together. And now if this was the case when velocities were unequal, and now if the velocities are equal, then in that case there are two possibilities. Either let's say there is a pencil, then I can say that it is clear that these are moving together, but what is causing this pen to move? There is some friction which is causing this pen to move, means because there is no other force on it, we cannot just have a simple direct conclusion of friction from this. It is possible that for knowing this, we need to introduce this a1 star and a2 star, means the acceleration of this body is given that friction is not acting. If the friction is not acting, we will calculate what would be the acceleration of this body is. And if a1 star is equal to a2 star, then in that case friction becomes zero between these two surfaces, because if both of the bodies are moving together, then there is no need of friction force to be acting, because friction force tries to oppose the motion, but relative motion, but there is no relative motion if they are tending to accelerate and move together with the same velocity. As long as they have the same velocity, there is no need of any friction. Now the other case, a1 star equals a2 star, then in that case, because these two have different acceleration, maybe at any instant of time t is equal to t naught, they have the same speed velocity, but due to this difference in accelerations, their velocities will tend to change. So because of that, there would be some friction acting between them, and in that case some static friction acts, and that static friction will be smaller than or equal to mu s into n. So these are the cases. And to solve any friction related question, first make cases of it. Like let's say there are 3 bodies here, or let's say 4 bodies here, and I am asked about the, let's say this block is moved with applied some force F, and there is some friction between them, and let's say this is frictionless. They have some masses. This is 1, 2, 3 and 4th block. So to study the friction, we need to make cases, different cases. For example, let's say all are sticking together, then if all stick together, what would be their mutual acceleration, and would the friction satisfy the acceleration of each? Would the forces and the friction satisfy the acceleration of these bodies if they have to move together? This is how we will proceed. And then we will make other case. Let's say all of these are sticking and this is slipping, and then third case we will say this is not slipping. Let's say this is not slipping, but this is slipping, and this is also not slipping, means these two are moving together and these two are moving together. So means in such way we will make different cases, and the next step would be to eliminate those cases which may not occur. Let's say the friction between these two is higher than this, then it is not possible that these two don't slip and this starts slipping. Means slipping of these two surfaces will not start before this if the friction is higher here. So it means we can eliminate that case. And similarly we can reduce the number of cases to very few numbers, let's say 1, 2, 3 cases, and we can solve for each of the cases, and the case would be dependent on the amount of force applied. If a small amount of force is applied, the body may move together. If the force starts increasing more and more, there would be some friction acting. This body tends to move together due to the friction, but friction has some limit, and there is maximum tendency of how much friction it can provide to these bodies to make them accelerate together. And after this certain value, they may not accelerate together. And let's say this starts accelerating, and if this starts accelerating, the mutual acceleration of all these three bodies would become a different acceleration value. Initially these all 4 bodies, if they had to accelerate, they would be accelerating with some a1 acceleration, but if this is slipping and these are accelerating together, they will be accelerating with some a2 acceleration, and that would require different friction force, not same as the initial. And if this also starts slipping, then these two bodies will accelerate together with some anti acceleration, and this will require a different friction force between these two. So we need to take the accelerations in each of the cases, and we need to satisfy the restrictions and limits in each of the cases. So let's solve a question. So here we have a question of, on a frictionless surface there are three blocks and there is some force applied by the pulley, and we are asked about the acceleration of the middle mass, and there is coefficient of friction mu, and we are given different cases of the force applied and asked for the acceleration of the two. Okay, then let's start solving this, but this will require larger space. So we have a question like this: frictionless surface means there is a block, let's call it 1 of mass m, another block, let's say 2 of another mass m, and block 3 of mass m again, and they have same coefficient of friction between them, and this is frictionless here, and these two are connected with a pulley with a string, and the pulley is pulled with the force F. So first observation would be that the forces are acting here on this masses due to the tension forces, which will try to cause some motion here, and this because this mass pulley is massless ideal pulley, there would be some 2t tension force in this direction, and this F force will be balanced by this tension, so it means the tension is equal to F by 2. So I can say that I can remove this whole setup, and I can say that this is pulled by F by 2 force, third, second, and this is the first, and this is also pulled by some F by 2 force. Now I will make cases. First case would be that all of the bodies, all of three masses are moving together. Means if none of them are slipping, there is no slipping at both surfaces, then in that case they will have the same acceleration, and the net force, we can treat this as a single body and of three mass. So the total force would be on this body, total force is F, and total mass is 3m. So that would be the acceleration of this whole body and also the acceleration of 2. So acceleration of 2 would become this, and the force on any particular body required, let's say the force on third mass at top, that would be equal to this acceleration a2 into the mass m, which is equal to F by 3. That is the force required on this mass, and same force is required on this mass, F by 3. This is the net force. This net force is required at each of these masses. So we, let's say there is some F1 friction here and F2 friction here. You know that this F1 friction should be lesser than or equal to mu s mg, and this F2 friction should be lesser than or equal to mu s 2 mg, because there is 2 m mass above, so the normal force will be 2 mg. And now for this mass, to get this F by 3 force net, we need F by 2, and because let's observe the direction of the friction, if there is no friction between them, this body will tend to accelerate in this direction with some F by 2m, while the acceleration of the body is, this body would be, if these two frictions are removed, let's say, then this body, let's say this friction is also not acting, then this body will have zero acceleration, so there would be some acceleration difference. Or let's say now I have included these two bodies also, still their combined acceleration would be lesser than this, so there is a difference in acceleration, means a star accelerations have some difference and velocities, and because their a star are different, there would be some friction acting, and because a star of this is higher in this direction, so friction on this body will be acting in this direction to oppose it, and F1 friction would be acting on this direction, and similarly F2 friction on this body will act in this direction, and F2 on this would be in this opposite direction. So for the third block, F by 3 should be equal to F by 2 minus F1, that is the force required on the body, which would be equal to F by, take this on the other this side, so we will get F1 is equal to F by 6, and we know that this it means that the friction should be equal to this force, but we know that friction is F1 friction is smaller than or equal to mu s mg, so it means this F by 6 force should be smaller than mu s mg. That is the condition here to get F by 3 force on this mass, and to get F by 3 force on this mass, we need, again same equation will be found, F by 3 is equal to F by 2 minus F2, so we get F2 is equal to F by 6 again, but F2 has larger limits, that is lesser than or equal to 2 mu s mg. So for this case, we need the F by 6, or F should be equal to or less than 6 mu s mg, and also smaller than or equal to 12 mu s mg. If this is true, then this is also true. So this restriction is necessary here to be followed. And another question for this second block would be F1 plus F2 should be equal to F by 3. So because this value has to be equal to f by 6 and this has to be equal to f by 6. This is equal to f by 3, which is true. So we know that the acceleration is f by 3m when the force is less than or equal to 6 mu s mg. There is only static friction here. For the second case, let's say because there is 2s mu g maximum friction here and 2 mu s mg here and mu s mg here friction. This friction is large a lot large, and we will see that this mass will not see this mass will not these two will not slip before this. Means if this is moving together and this is slipping, this type of case is not possible, or we can make such case. And we okay, let's make such case. Let's say 2 and 3 are sleeping while 3 and 1 are sticking together. So let's say, I know that this won't happen, but let's test it. So if this is moving together, then their accelerations would be same. That would be a2 is equal to total force is f2, and because there is slipping here, then these two masses would be together and there would be some friction f2 force, which is kinetic. So there would be, because this body should be having larger a star acceleration in this direction than this, because f2 force is moving these two masses while f2 forces moving this m mass only. So friction on this body would be backward and on this body would be forward f2. So we will get, and this friction would be kinetic. So the total force on this two system would be f by these two mass system is f by 2 and plus f2, which is, let's say f2, which is kinetic friction, so we don't need to put any limits. It becomes mu k mg, sorry, 2 mu k mg is the friction force, and dividing it all by the 2m mass, we get the equation of f by 4m plus mu k g. That is the acceleration of the a1 and a2, sorry, a3 and a2 in this case. Okay, sorry, this 1 and 2 are sleeping while this 2 and 3 are moving together. So that would be the acceleration of a2 and a3. And to get this acceleration, the force on the block 3 should be equal to this whole acceleration into mass, which is f by 4 plus mu k g m. That should be the force on this m mass, and there is some static friction possible between these two masses, and let's call it f1, which would act in this direction on this mass. So we know that f by 2 force was acting on this third block in this direction, and some friction is acting in this direction f1. So f2 minus f1 should be equal to this net force this body has, f by 4 plus mu k mg, which means this f1 should be equal to, this goes at the left side, it becomes f by 4 minus mu k mg, and it means that this f1 should be, because this f1 is small, this f1 should be smaller or equal to the mu k mg, then it means, sorry, mu s mg, then it means during the static friction this force can be maximum, or means this force will be equal to f1 as long as this does not exceed the limiting value mu s mg. So we get f by 4 should be smaller than or equal to mu s mg and plus mu k mg. And for this other mass, and we also need to observe one more thing, that is there is some friction force acting on this body, and when this friction force acts on it, the body should have a larger acceleration in this direction as compared to this one. That means this was the third block. For the third block we calculated this thrust friction, and for the second block we know that the f2 kinetic friction and the f1 static friction, they both should be equal to this force to make it accelerate with acceleration a2. That means f by 4m plus mu k g into, sorry, where is the force, this is the force f required. So this means, because this f2k here is kinetic, so it will become mu k, so 2 mu k mg, and this friction force f1 is, and f by 4m, sorry, f by, not 4m, only f by 4 plus this mu k mg. So this cancels this value, and we get friction force would be equal to f by 4 minus mu k mg, or we can say mu k mg, and this force should be smaller than or equal to mu as mg, which is the same equation as before. Means these two bodies which are moving together will we'll follow this equation. And the third, which is first mass m, that is having some force F by 2 and some friction force 2 mu k mg, 2 mu k mg, and dividing by the mass. So this is the total force on the body. So the total acceleration is F by 2m, and this, so that is the acceleration of the am after the friction acts here, kinetic friction acts here. Then we also need that this a1 should be greater than this a2, so that there is some friction in such manner. So because if this body gets lesser acceleration than this, then the direction of friction may change, or the value of the friction will also alter, because this assumption that this is slipping may or may not be correct. So we needed F by 4 should be lesser than or equal to this, and we get the acceleration of the body was, this acceleration of A2 was equal to F by 4m plus mu k mg. So it means that I want A1 to be greater than A2. It means F by 2m minus 2 mu k mg divided by m, that should be greater than this value F by 4m plus mu k mg. So it means that if I take this value on the other side, it becomes F by 4m, that should be lesser, that should be greater than this. Sorry, this is not m here, this is mu kg only, for the A2 mu kg only, and this when added with this becomes 3 mu kg. So we need that this force is greater than this 12 mu k gm in order to cause slipping. This force should be fixed, this force applied should be greater than 12 mu k mg, so to make slipping occur between them, but the maximum friction we have, but we saw that when the force is lesser than but we observe that when the force is greater than, what was the value, when the force is greater than 6 mu s mg, this top starts accelerating, these two starts slipping. So if these two start slipping when the force is equal to 6 mu s mg, then why would it stick together when the force is greater than 12 mu k mg? So it is clear that, and in the question mu s is equal to mu k is equal to mu, here I am using mu s and mu k for the clarification only. So it means that this case is wrong, because it says that slipping here should occur when this force is greater than this, when these two are sticking together, but this will start slipping when this force is that much. So we had one equation here which says that 4 mu s mg plus 4 mu k mg, means it says that the force applied should be, for these two bodies to not slip, the force applied should be lesser than or equal to 4 mu s mg plus 4 mu k mg, or we can say roughly 8 mu mg, which is smaller than this value for sure. Then it means that slipping case won't occur. This case won't occur, as I said before, because the friction is high here and slipping occurs here first, and after this the slipping can occur here. It is not possible that slipping does not occur here and occurs here before it. Now the third case, or let's say the second case, this is wrong, or let's say third case, when these don't slip, sorry, these two slip and this does not slip, when these two top slip, there will be some friction here which is equal to mu k mg, and there will be some friction force mu k mg here, some force F by 2 applied, and these two are, if these two are sticking together, this one and two are sticking together, there is some F by 2 force applied. If these two are sticking together, their total acceleration together would be equal to F by 2 force plus mu k mg divided by the total mass 2m, that is equal to F by 4m plus mu k g by 2. That would be the acceleration of 2. Given that, what is the condition for it? The condition is that the force on this block, sorry, first of all, this force F is surely greater than 6 mu s mg, because if it was equal to or less than 6 mu s mg, then this case will occur, this first case will occur, and after this force crosses this value, the slipping at top starts, and the friction becomes mu k mg. And now when these two bodies are accelerating together, their acceleration should be this, and when these two accelerate together, the force on each of the bodies should be equal to their acceleration into mass. Let's say the force on the mass m1 should be equal to this acceleration into the mass, which is F by 4 plus mu k g. That should be the force on the first block, and we know that there is some F by 2 force acting on this block, and some static friction between them can occur, and F1 would, let's say, F2 friction force plus this mass in this direction, and I just have to calculate the condition which satisfies this friction. I get F by 4 minus mu k gm by 2 should be equal to this F2, where F2 can be this friction should be equal to F2, and this is only possible as long as this force value is lesser than or equal to the maximum value of F2, which is 2 mu s mg. We are talking about the not sleeping case, that's why I used mus here, and this means if I take it on the other side, we get 5415. We can take roughly 5 mu mg divided by 2 should be greater than this 4, means this mu k and mu s are equal here, so that's why I can add them together in this manner, and the values will become 10 mu mg. So the force applied should be lesser than 10 mu mg. Here in this case it was 12 mu mg. In this equation we get 12 mu smg, but in this case we have 10 mu mg because these two are different cases. In this case all three were moving together and they needed different forces as compared to this one. The need of the force is now, the maximum force applied could be is now 10. So the limit for the force is from 6 means greater than this and smaller and equal to this, and if I exceed this value then all of them will start slipping. All start slipping, that would be the fourth case, and if all start slipping, this second block should be having this mu k mg force in this direction and 2 mu k mg friction force in this direction due to each of these blocks above and below. So the total force would be 3 mu k mg, which is equal to the mass and acceleration of the 2, and dividing it by 8, a2 becomes equal to 3 mu k g. So the a2 becomes 3 mu k g if and only if this force exceeds this value of, when the force exceeds the value of 10 mu mg. So in question, A option satisfies because it is equal to 5 and the acceleration is given equal to f by 3m, and the force was applied 5 mu mg. So this is satisfied. And the other case was of 8 mu mg. So 8 mu mg lies in this case between 6 to the 10. So this acceleration in this case of A2 is given by this, which is again true. B option is also correct. C option says there is 12 force and acceleration is this, which is again true because if force is greater than 10 mu mg, this would be the acceleration, and that should be the acceleration at 14 mu mg also, means at all other higher forces this would be the acceleration. So all of the options A, B, C, D are correct. So in short, we did just make the cases of each type of possible motions, and one was not possible, so we cancelled it out, and this was only correct. So that's it. And one more thing, if we are given any question and we are given a certain value of x, let's say force, and we are asked what would be the possible motion. So first of all, we should keep in mind that if the body is starting from the rest, then the static friction occurs first. Static friction occurs first, means it means that the first case we will check is for the all bodies moving together. The first tendency of all these bodies is to move together because of the friction, static friction between them. But if they cannot stay together, means if the conditions don't satisfy for staying together, only then we will proceed further and consider any sleeping case. Means the first priority is for checking if they are moving together. If it is true, then we will give it as answer, and if it is not true, then we will take the sleeping cases. We will make cases of the sleeping one by one. One example of it could be that, let's say there is a mass 2 kg and there is a mass 4 kg here, and it is applied with some 10 Newton force in this direction. There is constant friction between them 1 by 2, and this is frictionless surface. So when I calculate what is the acceleration of this 2 kg mass, first I will assume that because of the static friction acting first, there will be a tendency to move together. First I will check if they will move together. So 10 by 6 would be the acceleration, and to get 10 by 6 acceleration, this body needs a force of 10 by 6 into 2, which is 10 by 3 Newton force, but the friction on this body is equal to 10 Newton. So maximum static friction this body can apply is 10 Newton, and this is lesser than this value, then it means this body will move together with this acceleration. That's it. This condition is true. But now let's say I apply 40 Newton force. Now if I apply 40 Newton force, then the acceleration if they have to move together, first case is if they have to move together, then this would be the acceleration, and to get this acceleration, the force on this block would be 80 sorry 40 by 3 Newton, while the maximum friction force is only 10 Newton, and this is of course greater than this 10 Newton. It means this friction cannot provide this much force to make it stay together, so there would be slipping occurring. So this won't occur, and there will be slipping, and when slipping occurs, we know that there will be some mu k into the normal force, which is 20 Newton into 1 by 2. Let's say mu k is 1 by 2 again here, into the force. So 10 Newton is the maximum force which will accelerate this 2 kg mass. 10 by 2, which is equal to 5 meter per second square. That is the acceleration of this 2 kg mass, and this is applying some force on this block in this direction, 10 Newton. So the net force on this body is 30 Newton in this direction, which will cause 30 by 4 acceleration in this direction, and we will see that this value is greater than this value. So it's of course greater than this. It is 7 point something 25, sorry 7 point, I guess 7.5. This is 7.5, so of course greater than 5. So now we will try this question number 26. Okay, read it. So there are two blocks, massless strings, and there is coefficient friction with m1 and m2, 3 by 4 and 1 by 4 respectively. And assuming the string to be taut, find the common acceleration of the two masses and the tension in the string. Let's go. So for solving this type of questions, we should first understand that the friction force will act first. If there is no tension initially there, the friction force will occur first, and then if there is any exceeding force, there is some force that is exceeding the friction, then that force will pass to the tension. Means that remaining force will pass to the tension, but the first force that will act would be friction. I will explain it here. So let's say this is mass m1 and this is mass m2. It is given that m2 is 2 kg, m1 is 4 kg, and the coefficient of friction here is 3 by 4. It is here 1 by 4. So the friction force here maximum is 3 by 4 into 4 into 10, which is 30 Newton. Maximum friction force here can be up or down 30 Newton, and on this block it is 5 Newton, sorry 20. It is 2 by 4 into 10, which is okay 5, and this is larger mass and larger friction also. Yes, okay. So there is maximum 30 Newton force here, and component of force along this direction would be equal to the angle. Sorry, I didn't took the angles here. The angle is given 37 degree. So at 37 degree, this cos theta would be equal to 4 by 5, and the friction force maximum would be equal to mu s into mg cos theta, that is equal to, for this mass, this is 4 into 3 by 4 into 10 into 4 by 5. So it is cancelling this 4 and 5 to the 4 there. The maximum friction force would be 24 Newton here, and for this the maximum friction force would be again cos theta 4 by 5 multiplied by 1 by 4 coefficient of friction into 2 kg mass 20. So the maximum friction force here would be 4 Newton. So it is 4 Newton here and 24 Newton here. So first of all of these masses, first we will assume that if no force friction acts, then what would happen? These two masses will accelerate with some g acceleration, and okay, so first of all, if this friction does not act, then this is at rest and this will tend to accelerate with g, and similarly this will tends to accelerate with g here. So there would be surely a friction in the upward direction, and similarly, and let's say this block is, let's say, heavier, and this is the mg sin theta component of it would be 4 into 3 by 5 into 10, which is 24. Okay, let's say again 4 into 3 by 5 into the 10 m g into sin theta, which is 24 Newton. So the 24 Newton force is applied in this downward direction, and 24 Newton is also the maximum friction force here. So if this body tends to move downward, this whole friction force would be cancelled. This whole force by the gravity is cancelled out by the friction force. So it has no force here right now, but there is a string connected to it, and this body, as I told before, first we will apply the friction force. This body has net zero force, if I don't consider tension here. Similarly, on this body, there would be 2 into 3 by 5 into 10, 12 Newton force in the downward direction, where this 4 Newton friction force will act first on this body in the upward direction to cancel this out. So the net force on this body would be 8 Newton. So if this body had to move down, the friction would act upward and cancelling out all this force, and this mass, if it tends to move down with 12 Newton force, 4 Newton is cancelled out and 8 Newton is left, and this 8 Newton is causing these two masses to move together with same acceleration. So this 8 Newton divided by the masses of this, which is 2 plus 6, which is 8 by 6, that would be the acceleration of each of these masses. So 8 by 6 is the acceleration of this mass, which is 4 by 3, and if this body has acceleration 4 by 3, okay, we have answered the first part of the question A, which is the common acceleration, which is 4 by 3. And now the next part, tension. Because this body has net zero force due to the friction and gravity, so now the tension force is only providing this accelerations. 4 by 3 is the force of 4 by 3 is acceleration multiplying by the mass. It should be equal to the tension. So this is equal to 16 by 3, that is equal to tension. So that is our answer here. T is equal to 16 by 3 and acceleration is equal to 4 by 3. So that's how we'll solve. First, the friction forces will cancel out, or let's say if instead of this I had to pull this mass, if I remove this part here, and if I had to pull this mass in the upward direction, then in that case, if I had to make it just start moving, then for that case the tension should be causing it to tend to move in this direction. If I remove the friction, this body will tend to move in this direction. So it means that if there is friction, that will apply some force on this body in this downward direction. So the friction force, which is 24 Newton maximum, and gravitational force is also 24 Newton. So the T max, so that this block does not slip, would be equal to 24 plus 24, which is 48 Newton. That is the maximum force I can apply so that it does not slip. And if I apply more forces, let's say 50 Newton force, then 50 Newton minus this friction force and gravitational force would be 2 Newton, dividing by mass, that would give me the acceleration of the body of this block. So first friction acts, then tension acts. That's it. Now looking for some more cases in the same question. Let's say here I said that these two friction forces were equal, taking G is equal to 10. These two friction, the gravitational force in this direction and the friction were both equal, which were not making it able to move. But let's say this friction becomes smaller, then this body will have some tendency to move downward, and this block, it is also having some tendency to move downward. And let's say the maximum friction force here becomes, let's say if it is having 24 Newton in the downward direction, let's say this has maximum friction possible as 4 and 4. So let's say the maximum friction force it has is 16 Newton. So 16 Newton minus 24 Newton minus the 16 Newton upward will cause this body to have a tendency to move downward with some 8 Newton force. So that will be the 8 Newton force, with which this 4 kg mass will be slipping with 2 acceleration of 2, and this also has some 8 Newton force in this case, and this will tend to accelerate with 4 meter per second square. So this is higher than this. It means that the string will remain taut and they will move together, and if they will move together, then in that case we will take both of the mass, 2 plus 4, which is 6, and the total net force applying here, which is 8 at 16. That would give the total acceleration of each of them, which would be intermediate. As we can see, it is lesser than 3 but greater than 2, so between 2 and 4. Now if I say that this net force on this body initially, if I remove the tension here, this mg sin theta minus mg cos theta mu, if it was, let's say, equal to 2 Newton, then in that case it would have some acceleration 1, and while this has the tendency to accelerate with 2 acceleration downwards. So it is clear that this is moving faster, then the spring will slack and the tension will become 0, and it will keep accelerating with 2 and it will accelerate with 1 as long as they don't hit each other. Okay, so now let's take one more question of the pseudo force. So a question from the pseudo force. Let's say this question number 71 here from the mains, and there is a mass m and a small mass m. The mass is given and we are asked the acceleration of the wedge with respect to the ground. Sorry, acceleration of the block with respect to the wedge. So if the system is released from the rest, then first of all, in such case of question, in such type of questions, when let's say this block is not moving, if this block is not moving, wedge is not moving, then this m would apply some normal force on this block m, because it has some tendency to go downward, and in this it has some component in this direction which is g cos theta, but this is opposing it, so there will be some normal force acting. Let's say it is not moving right now, so normal force will be some n1, and when this normal force acts on this body, because of this force, some component in this direction, this body will start accelerating with some acceleration a, and as this body starts accelerating, this normal force between these two masses will also change, so this acceleration will also change. If this changes, this changes, this changes, this changes. So in such cases, when there is a cause, which is force causing some effect, that is acceleration, and the effect, which is acceleration, is causing a change in the cause. So cause causes effect, and effect changes the cause. So for solving these questions, we have to assume the value of this effect a. So let's say this block of mass m is moving in this direction, accelerating with this acceleration. Then if now I can use the pseudo acceleration frame, because the motion of this mass would be complex as it is moving here and it is moving downward. But if I sit on this wedge, I can see that this block would be moving along this path only in this frame. But if I sit on this frame, I need to consider a pseudo force also. There is no problem in any taking any frame. We just have to consider the pseudo forces. So pseudo force is acting in this direction. This is 30-degree angle. So first of all, and one more thing, that is normal forces act only to balance the forces, and they don't occur by own for no reason. Means, for example, let's say what I'm trying to say is that there is some acceleration force component mg cos theta by the gravity in this direction, and because of this there will be some ma sin theta in this direction. Then theta is 30-degree, and there will be some ma cos theta here in this direction, and some ma sin theta in this direction. So if the body, this mass has to be in contact with this mass, so this acceleration in this upward direction, this normal provides some force in this upward direction to this mass, and so we can say that this mg cos theta, which is in this direction, should be equal to ma sin theta plus this normal force which is in this direction. So it means mg cos theta minus ma sin theta, that should be equal to the normal force. That is the first equation. Second equation, what we actually want to calculate is the acceleration of this mass would be equal to, let's say on this wedge, would be equal to the total force ma cos theta plus ma sin theta divided by the mass of the block. I want to calculate this value, but there is a variable a here, and so to calculate this value, I will use this normal force and make one more equation. On this normal force is acting in this direction, and this is 30-degree angle, and this is 30-degree angle. So this component of this normal along this horizontal direction would be n sin 30-degree or theta. So this force in this direction, because of this normal, will cause this mass to accelerate, and this ma acceleration would be equal to n sin theta, and we know that n is equal to mg cos theta minus ma sin theta. Now multiplying it by sin theta, we get it is equal to ma. So now from this equation we can write that taking a on the other side, we will get ma plus ma sin square theta is equal to mg cos theta. Now this mg, which is a small mass, and this is also small mass, so we get a bracket m plus m sin square theta, where theta is 30 degrees, so it becomes m by 4, sorry 30 degree 1 by 4, okay, right, is equal to m into g cos 30 degrees root 3 by 2. So this acceleration becomes equal to mg root 3 by 2 and divided by m plus m into 1 by 4, and the masses are given that m is 16 and m is 8, so it becomes 8 by 2 into z root 3 divided by 16 plus 8 by 4, which is 2, 2 4 is 16, and this becomes 18. So overall this is g not 9, so it becomes 2g root 3 divided by 9. This is the value of a, and now substituting the value of a here to get this acceleration a, so a equals to m bracket a is equal to 2 root 3 into z divided by 9 into cos theta, which is again root 3 by 2, plus m into a, which is 2 g root 3 by 9, sorry m is outside, and sin theta, which is 1 by 2, so 1 by 2 cancels, and root 3 becomes 3, 3 3 is a 9, so we get g by 3 plus g root 3 by 9 into this m, and also we have this m mass here which gets cancelled from the denominator. So the acceleration should be equal to this g bracket 3. Okay, so we made one mistake. It was mg cos theta sin theta minus ma sin square theta. So it is right that ma sin square theta is here, but I have to take mg cos theta into sin theta here. So this value will become 2 sin theta divided by 2, which is, okay, this is root 3 by 2 into 1 by 2, so it becomes root 3 by 4. So this value should become root 3 by 4. The denominator will remain same. So I just have to divide it by 2 also again. So it becomes g root 3 by 9. Sorry, 9. This acceleration s would be equal to g into root 3 by 9. Okay, and one more mistake I did here. It was this ma cos theta is right, but this is mg, not ma. This was mg sin theta. So this was the expression for a. Now I have calculated this value a. Now calculating m cancels these two values. I get only a cos theta plus g sin theta. So it means g into root 3 by 9 into root 3 by 2 plus g into sin theta, which is 1 by 2. That is equal to 10 by 6 plus 10 by 2. That is equal to multiplying by 3. Here it becomes 6. 40 by 6, and that is, sorry, we can write it as 4 by 6g. Okay, 4 by 6g, which is equal to 2 by, okay, 40 by 6, which can be written as 4 by 6g, 2 by 3g. So the answer is D option, 2 by 3g. Now let's do one more question. This is question number 68. An arrangement. These are the acceleration of these masses m1 to m4, and I am assuming that they are given in the same direction because they are not telling me the direction. So I have to assume that they are all moving in these are all values taken in the same direction. Now I have to check which equation is correct, but before that I have to think of all the relations about this acceleration. So first pulley goes down with some a1 acceleration, this moves down with some a2 acceleration, this another pulley, this moves down with some a3 acceleration, this moves down with some a4 acceleration.